Today I will going to talk about issues on design of nomadic devices in Brazil. Just to talk about a little bit about me. I am an industrial designer and I have a doctorate and master degree in design and ergonomics too. I am here for foreign international exchange. I am a foreign researcher here at IFSTAR. And I'm also professor at the PUC-Rio University. PUC-Rio University is a private university in the middle of the city of Rio de Janeiro. We have more than 18 students. And PUC-Rio has 4 main academic centers where I am part of the Arts and Design Department in the Center of Theology and Human Science. Arts and Design Department has 4 main axes. The first one and the most important is the undergraduate program with a Bachelor in Design and Bachelor in Architecture and Urbanism. And we also have extension courses with continuing education, service laboratories, social programs. And the other most important program is the graduate program with a Master in Design and a Doctorate Design. Both are the first in the Latin American programs in design. We have also a specialization course with animation, web, ergonomics, and others. And the fourth axis of the department is the research, with some research laboratories. So our research is based in the concentration area Design and Society, with 3 research lines: communication and cultural arts, technology, education and society, and ergonomics usability research line where I work. And we have also 10 design labs like communication design, emotion design, eco design, and the LEWI lab, that's a laboratory of ergonomics usability of interface in human technology systems. In our Ergo Lab, we work in 5 main themes: ergonomics and usability of product and process. We have an example of a master dissertation, biomechanical constraints of SNIPE athletes. The second theme is ergonomics in built environment, is most related to architecture. As an example, a doctorate thesis, the influence of airport architecture on wayfinding. And we have also the theme ergonomics and usability of informational systems, where we study communication not presented in a computer interfaces, but all the communication, how to present the information to the user. And we have also one of the most studied theme nowadays is the ergonomics and usability in human-computer interactions, where we study the user experience, interface design, mobile device interactions, and so on. And the last one is the ergonomics in transport system, where we study the relation of the user with all systems related to the transport. So all work we do in our lab is based on the concept of ergo design. Ergo design is a concept that eradicates the disagreements between ergonomists and designers. So in the past, designers saw that ergonomics issues as a complicated elements to be applied in the design process of development. On the other hand, the ergonomists could not see the dynamics of the fast-paced design process. So failing to communicate their recommendations. So at PUC, we try to eradicate this disagreement. We work together to create a user-oriented interfaces. So our work, our research, our classes are based on human-centered design process, where you use analysis, design, and evaluation methods and techniques during our work. As an examples of methods and techniques that we use task analysis combined with contextual inquiry to know about the actions and the cognitive process that users perform to accomplish tasks, and also to understand the user's needs and the context of use. We also apply questionnaires for both surveys and satisfaction evaluations after some usability tests, or after other interface evaluation. So we use this type of questionnaires. Other method that we like to use is card sorting, both manual card sorting or remote card sorting, to discover the representation of or the user mental models for a set of information items. We need to know how the users think about organization of a labeling systems of a system, and this helps us to define the system information architecture. As a usability expert, you do also heuristic evaluations to see if, to judge some interface, if they meet or not, if they follow or not usability principles. We normally use the Nielsen heuristics, the 10 Nielsen heuristics, and we also like to use usability tests. We have a small usability lab in our lab to conduct this kind of tests, but we also do tests, remote tests in the middle of the street, for example, inside a vehicle, so to evaluate the interfaces. All the methods and all our work is based on some usability design principle from these researchers like Bastian Scapin, like Jacob Nielsen, Ben Steinman, Patrick Jordan, and Donald Norman. Some examples of these principles. The first one is compatibility. So for easy learnability, the interface should be compatible with the user's expectation from the use of other systems or other environments. In this example, we have the interface of iPhone that use switches in the same way that you virtual switches in the same way that you use physical switches. When you turn on, we have to flip to the right, to turn off, have to flip to the left. Other example of principle is eligibility. Is a very well-known principle. Here in this example, we have two types of alignment of a test. So when we have a test that is justified, we can have some holes, and if you have that is not good for reading, and if you have a test that is aligned on the left, to have other rows in the right side, but it's good to be read. But this is our old examples. Nowadays, the same interface, the same journals, that is Le Monde and Le Parisien, they use different alignment. Le Monde use the left alignment, And Le Parisien use justify, but use the feature of hyphenization. Another principle is information density. So to decrease the user's workload from a perceptual and cognitive point of view, the system should reduce the information density as possible. This is the concept of minimalist design. As an example is the Google search engine, where there is only a box to enter a word. Another example is the Apple iPod. And good example, but a bad example is the image on the right side, that to find in the navigation system in Brazil, to find a point of interest, you need to pass through a lot of screens driving to find this information. So it's a lot of information just to find a simple thing. Another principle is the immediate feedback. All the actions that performed by the user should be recognized and should be indicated as a system response. This is good to establish a user confidence and a user satisfaction too. So some information talking about the mobile devices, nomadic devices. Some data about Brazil. Nowadays we have more than 258 million of mobile phone lines, which means a teledensity of 131.6 per 100 inhabitants. So we have more phone lines than inhabitants in Brazil. But we have only 14% of smartphone adoption. Only 14, if you consider a huge country like Brazil. This is more than 27 million of smartphones. If you compare with other countries like France, that has 38% of smartphone adoptions. Brazil has more units of smartphones than the other countries that have a huge adoption. So in Brazil we have the same application stores, and Apple App Stores has a lot of navigation systems available, and here is the rank of the top 10 navigation applications in Brazil, and the first one is a well-known navigation system here in Europe. Is TomTom Brazil. The application is TomTom with the Brazil map, and we have all others. Systems, navigation systems like this one and this other one, they are available in other countries. So in order to compare these two of these applications, TomTom and Brazil I Go Primo, we conducted a study to analyze the design interface. So in order to evaluate the potential of the visual distractions of these systems related to the visual demand afforded by the systems, we applied the extended keystroke level model to estimate the total time to perform typical tasks. The extended keystroke level model is a model that estimates the total time of tasks performed in in-vehicle systems, in-vehicle information systems. The model is based on the simplest variant of Gomes models, a well-known model in HCI, in human-computer interactions, called keystroke level model, and is also based on the occlusion technique that estimates the total task time performed with interruptions. This second technique assumes that the driver, while driving, user in vehicle system must balance his vision, alternating between looking at the road and reading the system display and controls. So these models use 3 parameters. The first one is the total task time under an occlusion condition, that refers to the total time required to perform tasks without interruptions. The total shutter open time is the total duration of all intervals of vision while performing a task with interruptions. And the R value is the ratio of the duration of the total shutter open time and total task time under the condition, which means how easy a task can be resumed. So the first stage of the model, we need to do a task decomposition in goals and sub-goals and actions and cognitive process, and then allot some values, some time values, to obtain the total task time under an occlusion condition. And in the second stage of the model, we need to distribute all these actions and cognitive process along intervals of vision and occlusion. The rectangle in gray are the occlusion intervals, and the rectangle in white are the vision intervals. So after that distribution, you can obtain the total shutter open time and the R value in this second stage. So if the total shutter open time is less than 20 seconds and the R value less than 1, the task could be performed with the vehicle in motion, according to some American guidelines. So in order to compare the two applications, we apply this model in these 3 tasks, 3 typical data entry tasks. Task 1, set a destination by address. Task 2, select as a destination the gas station closest to the current position. In the task 3, restore a new home address. So this is the results of the model. We can see that only on TomTom app, all the tasks can be performed in less than 20 seconds. And just the task 2 in iGo Primo meets the 20 seconds criterion. For the R values, all the values obtained are quite reasonable, which means that the design solutions are appropriated to perform the task with interruptions. On task 2, one of the reasons that iGo Primo spends more time is because the user, after entry the address data, the user must confirm the address and then confirm the route planned. In TomTom app, these 2 steps is combined in 1 step. After enter the address data, the system immediately calculates the route. On the task 2, select as a destination the closest gas station. iGo Primo has a better solution because 2 steps in the point of interest selection is combined in 1 screen. In TomTom, first we need to select the reference of proximity, and after select the point of interest category. And in iGo Primo, these 2 steps are combined in 1 screen. And for the task 3, store new home address, TomTom has a better solution because the system uses the iOS standards. So instead of use a lot of menu screens in a deep structure, we can find all the options by scrolling the screen. This is a very good solution when you are designing an interface for a specific operating system. So, using the scrolling feature makes the system structure less deep, and the user doesn't need to navigate through many screens. So we can conclude that the visual demand is directly related to the amount of screens that are presented to the user. The more screens, the greater are the chances of driver distractions. And the other important thing that we can conclude is that we need to apply the operating system's standards and features to make the system easier to learn, and also to meet the usability principle compatibility. Thank you.